values of f of negative 6 and f of 5. All right, so let's write a plan that we're going to use to solve this problem. Our plan is as follows. We're going to find f. So what you want to notice in this problem is that we're finding f evaluated at a particular x value, but what are we given? We are given the graph of f prime. Okay, so to find f given f prime and also a point, given f prime and a point, what do you think the operation is going to be? So if you have f prime, to go from f to f prime, you differentiate, right? So what do you do to go from f prime to f? You integrate, okay? So the plan is as follows. To find f from a given f prime and a point, we're going to integrate. All right, we're not just going to integrate. Since we're given the points to be specific, we are going to use FTC I. Okay, so we're gonna to find f given f prime, we're integrating using FTC part 1. All right, so that's how it's going to work. Let's go ahead and write down the formula that's going to guide our problem solving process. The formula FTC1 is as follows. So f of b minus f of a, you can think about this as y2 minus y1, or the rise, okay? The rise is equal to the integral of the derivative f prime of x from a to b, of course, with respect to the x. Okay, so we have rise I dab. There you go. Okay, so the rise is the integral of the derivative from a to b. Okay, so let's go ahead and start with the first one. The first one is f of negative 6. So we want to find f of negative 6. We're given the graph of f prime. I copied it on the side here so we can just refer to it with ease. We're given the graph of f prime, and we're also given the point f of negative 2 equals 7. Okay, so to find f of negative 6, we're given f of negative 2 equals 7. All right, so this given point coordinate can easily help us to determine what a and b are. Okay, so we have a number line. Which one is to the left of which? Negative 6 comes first and then negative 2. All right, so when you're setting up your integrals, you want to make sure you're setting it up in ascending order. So which alphabet comes first? A, right? So this is A and that's B. Very important. Okay, so since negative 6 is less than negative 2, as you can see my number line right here, that follows that A is going to be the smaller one, B is going to be the bigger one. Okay, and we also know that f of negative 2 is 7. So what we're looking for is f of negative 6. So f of negative 6 is a mystery here. All right, let's set up our integral. Using FTC part 1, rise I dab, we have f of b. So b is, what is b? Negative 2, right? So f of b is f of negative 2 minus f of a is equal to the integral from a to b. So a is negative 6 to negative 2 of the derivative f prime of x dx. Alrighty, so let's do it. So we know that f of negative 2 is given to us. F of negative 2 is covered up here. F of negative 2 is 7. We also specified it here. So 7 minus f of negative 6 is going to be, now if you're given the graph of a function, in this case f prime, and you want to find an integral over an interval, what do you do? What is the connection between the integral and the graph of the function that you're integrating, a definite integral? The connection is the following. Let's remind ourselves. We have Navier-Stiller and we're looking at the integral. All right, so when you're looking at the integral, it could be found using A, which is the area. Okay, so in this graphical representation, the integral from -6 to -2 of f prime is the same thing as the area between the graph and the x-axis from -6 to -2. Okay, and also pay attention to where your area is located. If it's underneath the x-axis, your area will be negative, so that's important. All right, so what we're going to be looking for here, this integral is equivalent to the area, let me change my color, is equivalent to the area from -6 to 2. So the area from -6 to 2 is basically this triangle that we have right here, okay? So the area of the triangle from -6 to -2. Since it's a geometric shape, this area is exactly what the integral is. All righty. Okay, so let's go ahead and figure that out. Well, we can add 7 to both sides, right? Well, let me set it up first. So we have 7 minus f of -6. The formula for area of a triangle is 1/2 base times height. Okay, so for this triangle, the base is 1, 2, 3, 4. The base is 4, and the height is 2, 1, 2. All right, so the area is going to be 1/2 base, which is 4 times height, which is 2. Okay, so f of -6 is going to be, so we can simplify this, the 2's cancel out, so we have 4, and then you subtract 7. Oh snap, I forgot my minus. Subtract 7 from both sides, like that. And then negative f of -6 is -3, which follows that. Divide both sides by -1. F of -6 is equal to 3. So that's the answer to the first part. All right, so we're going to find the next part, which is f of 5. We're going to follow exactly the same procedure. Okay, there's nothing different there. So now we want to find f of 5. All right, we're still given this fact that f of -2 is equal to 7. We're going to use this so many times. So let's order our independent variables so we set up our integral correctly. Okay, so -2 is smaller than 5, so we want to order it correctly. So -2 is smaller than 5, so which is A and which is B? A is the smaller one, -2 in this case, and B is 5. Alrighty, so let's just write it again for emphasis. Since -2 is less than 5, that follows that our A value is the smaller of the two independent variables, -2. A is -2, and the big B is 5. And we know that f of -2 is 7, which is given. And f of 5 is the mystery. That's what we're looking for. Okay, so let's apply FTC part 1. Rise like that again. So f of B is going to be f of 5 minus f of -2. That's f of B minus f of A. Rise equals the integral of the derivative f prime from A to B, so from -2 to 5 dx. Okay, now f of 5, we know what f of -2 is. F of -2 is 7, that's given, equals. Now the integral from -2 to 5 of f prime using the graph, how do we do that? We already talked about that earlier, that graphically your integral is the area between the function and the x-axis. Okay, we talked about Navier-Stiller here. And remember that when your area is beneath the x-axis, that region will have a negative integral value or a negative area. Alrighty, okay, so let's do this. So we're going from -2 to 5. So from -2 all the way to 5 is a combination of two geometric shapes. We have a semicircle underneath The x-axis will show have a negative area, and we have a triangle above, which has a positive area. So to do this, we're going to be looking at the area of the semicircle from -2 all the way to 2. And we're going to add it to the area of the triangle from 2 to 5. And that will give us what this integral value is. Alrighty, so in this particular case, we're going to be flexing our geometry muscles to do this problem. So the area of a circle, semicircle, is pi r squared over 2. So area of a semicircle is pi r squared over 2. Area of a circle is pi r squared, right? And then we already know that the area of a triangle is 1/2 base times height, or base times height over 2. It doesn't matter. Same thing. Okay. Area of the semicircle is going to be, let's not forget the minus because it's upside down. Pi r, which is 2 square. That's for the circle, divided by 2 for a semicircle. Plus, the area of the triangle is 1/2 base times height, 1/2. The base is 1, 2, 3. And then the height is 2. Like that. Let's go ahead and simplify that. We're going to have f of 5 is equal to, so we add 7 to both sides, okay? Simplify this. This is -4 pi over 2, which reduces to -2 pi. And then these two 2's divide out, so we have plus 3. And then we add 7 to both sides of the equation, plus 7. Okay, so this simplifies to f of 5 is equal to 10 minus 2 pi. All right, so how was this question scored? This was a 3-point question. Appreciate it. If you found the contents of this tutorial helpful in your preparation for the AP exam, do give us a thumbs up or like. Your positive feedback is very valuable to us. If you have any questions, comments, just post it in the comment section below, and we'll be more than glad to respond and support you. Don't forget to subscribe to our channel. We upload videos to our page on a weekly basis, so do subscribe to get updates. More support resources to help you pass the AP exam can be found at our website, mathgotserved.com. Thanks again for watching, and have a wonderful day. Goodbye.